No matter what you're building, games, web apps, or even backend systems, you will encounter the observer pattern. As a professional web developer with over 3 years of experience, I've seen firsthand how these patterns power real world projects. And this video is mostly for those such as myself that have always had an interest in game development, being a web developer. My goal is to bridge the gap between game and web development and show how there are many similarities between the two. I'll show you how reactivity in React, observables in Angular, and signals in Godot all tie together. Stick around because by the end, you'll not only spot the observer pattern anywhere else, but you'll see how it can actually make you a better developer. Before we continue, let's quickly understand what the observer pattern actually is. Imagine a radio tower broadcasting a signal. Any radio tuned into that frequency will automatically receive the broadcast. The tower doesn't need to know about the radios, it just sends a signal. And the listeners respond. That's exactly how the observer pattern works. You have a subject that emits events, and multiple observers listen and react whenever those events occur. In web development, React, Angular, and other frameworks. Yo, Jesus Christ, I can't fucking speak today. Oh my God. Let's try again. In web development, React, Angular, and other frameworks use this concept to update interfaces and pass around important information throughout the application without having a direct reference to it. So it makes it a lot simpler. So now that we understand the observer pattern, let me show you how it shows up in React. I built a small React app that uses useState to keep track of a counter. So if I click this button, we can see that this count is being updated. Under the hood, React utilizes principles of the observer pattern, but it's not a one-to-one representation. With useState, React sets up an internal subject that tracks the state value. Each component using that state becomes an observer, and when you call the setter function, React's internal system updates the value and notifies those observers by triggering a re-render. So while you don't see a traditional subscribe method directly, React is quietly doing it behind the scenes. Take a look at a more traditional approach and explicit implementation of the observer pattern in React. You can take a look at Redux. But for the purpose of this video, I wanted to show how the similarities are there. Now, let's take a look at Angular. I created the exact same UI application. So here we have React, and over here we have Angular. In Angular, observables are a more traditional implementation of the observer pattern. With RxJS, an observable acts as a subject that emits values over time, and anything that subscribes becomes an observer. So while React hides the observer mechanics behind state and re-renders, Angular exposes it directly through RxJS. And whenever I click on the button, we call this increment count function. This function, what it does is that it broadcasts a change on the behavior subject. If we remember our analogy from earlier before, the behavior subject is basically our radio tower. When we click the button and increment count executes, we're essentially broadcasting that change. Once the change is being broadcasted, any listeners will get that value. So within here, we're subscribing to it, which is a key component of the observer pattern workflow. So let's open up DevTools. And if I click on this, we can see that this value is being logged here because this is actively listening to this behavior subject. Okay, finally, the entire point of this video of how the observer pattern is implemented within a game engine. In Angular, it was observables, and within Godot is known as signals. So here we have a script called button.gd. This script is attached to this button node over here. And within Godot, many nodes already come with many signals attached to them. So in this case, the button node comes with a signal called pressed. So whenever the button is pressed, it emits a signal to the script saying this button was pressed, as we can see here. Whenever this button is pressed, we generate a random color and we emit that color. Now, this is our own custom signal. This is not by default that comes with the engine. We create this. And right here, we're starting to make use of the observer pattern. We create our own signal, and then we emit the value. Now, wherever this is being consumed, that's when it will be applicable. So if we take a look at this panel 2 and panel 3 scripts that attach to the corresponding panel, we can see here that we're connecting to this I need money signal. And whenever we emit a new value, these get executed, right? This callback function gets executed. If I were to click this button, these two are listening to it independently, and all they know is that I clicked this button, and this button emitted an event, and they just happen to listen to it. Now, the one on the left didn't work. Why? Because again, since Godot comes in with many pre-built signals, this one only triggers when you hover over it. And let's say if down the line I decide, you know what, I don't think I want panel 3 anymore, then we can just very simply comment out that. So it makes it very simple to plug in and play of where you want that stream of data to go to. So that's the video. Whether it's reactivity in React, observables in Angular, or signals in Godot, the observer pattern is the thread connecting web development and game development. If you can recognize these patterns in web apps, you're already halfway to understanding event-driven game systems. Your skills are more transferable than you think.